Hi, my name is Sandy, and today, along with Nancy, Emma, and Ali, we're going to be presenting our project on how a subtype of the adrenoreceptor, known as the alpha 2A adrenoreceptor, interacts with the drug norepinephrine.
Alpha 2A adrenoreceptor is a G protein receptor. The binding of norepinephrine to the receptor inhibits the release of norepinephrine, which is believed to play a role in depressive disorder and schizophrenia. The goal of this project is to create a 3D model based off of the crystallized alpha 2A adrenoreceptor and to showcase the binding of norepinephrine.
We began our design process with a prototype made from materials provided in the UNC Maker kits. Our preliminary model involved a clay structure in the center of 7 helices that were hot glued together. Our next step was to develop sketches of our norepinephrine molecule and the 7 alpha helices that join together into a cylinder. We used the Ostopovici computer-generated receptor to scale these drawings. Next, we transferred these drawings into a digital model using Tinkercad. Then, 2 members of our group completed the required 3D printing online training as well as the general Be a Maker 101 training to operate the tools in the UNC's makerspace. We then used the Ultimaker 3D printers to print our receptor and molecule using generic CPE filament. We painted our successfully printed pieces with acrylic paint to distinguish between them. With hot glue and magnets, we plan to assemble our full receptor and ligand into its binding pocket once all pieces have successfully been printed.
So for troubleshooting, we faced a couple initial issues with the sizing in Tinkercad. So the components were actually too large for the 3D printer, so we had to scale them down by 50%. We also faced issues with printing a standing receptor, so we opted to lay the helices out flat. The additional 4 helices were originally interrupted during 3D printing, but we were able to reprint those later. And lastly, a clay form was needed in order to stand up the 3D model. This 3D representation will help us understand the specific binding region on the receptor and allow for improvements in drug design. It aids in exploring the configuration of the receptor that can only be seen through a microscope, and allows for comprehension of receptor structure at an introductory level. We can see the overall binding area of the norepinephrine molecule, and also identify residues and norepinephrine targets through hydrogen bonding at helices 3 and 5. In the future, we hope to be able to model a more specific receptor focusing in on the residues involved in the binding affinity of the norepinephrine molecule.